So question 3 talks about a block of weight 80 Newton that is pushed at a distance of 60 centimeters up in the inclined plane at 30 degrees to the horizontal. There is a frictional force of 25 Newton between the block and the surface. That means this force is 25 Newton. So question is, what is the work done, G, against the gravitational force, and the work F, WF, done against the frictional force? Okay. So basically, work is going to be associated to force and in the direction of the displacement. We are basically, going to figure that out. So frictional force X in this direction, right? And the frictional force basically is acting parallel to the slope. And so is the distance given, that's 60 centimeter. If we want to find out work done by frictional force, we can just do 25 times 0.6. So 25 times 0.6 is going to be 15. That means we are at either option B or D, right? So that's basically the work done by 15 frictional force. Now, if we find out the work done by this weight, so what we need to analyze is that we have to have this component of the weight, right? Because that's the parallel component to the weight. Also, if we are unable to solve that out, what we can do instead is we can just find out the vertical height of this. So if we can proceed with the works components parallel to the inclined plane, or if we can proceed with the height of this, so it is either way the same thing. So right now I'm more likely going to find out this height. So if this triangle has 60 centimeters length here and this angle is 30 degrees, so this height is going to be what? So this height is going to be 60 sine 30, right? And that's going to be 60 cos 30, right? So 60 sine 30 would be, as in we can say 0.6 sine 30, not 60 sine 30, because we are going to convert it into meters anyways. So that's 0.3 meters. So we have weight, that's 80, and we have basically height. So work done against gravity would just now be potential energy. So instead of writing M and G separately, we have 80 times zero point 0.3. So that saves us a lot of time. We can multiply 80 with this. So what we are getting is 24. Do we get this? Let's try next question. That's question 4, what it says. So it says power is transferred through a machine as shown. That is power input. Okay. And that's power output. Okay. That's power loss. Okay. What is the efficiency? The efficiency is useful power output over total power input. So that's basically PO over PI. That is going to be simply D. Nothing difficult here. Very easy. Okay. Let's try this. Question 5. So question 5 here basically deals with what? Question 5 here deals with a cylinder that is heated, causing the air inside to expand at a constant pressure of this much pascals. Okay, the expansion of the air causes the piston to rise. So this is going up. Okay. And 11 kilojoules of work is being done. Okay. What is the cross-sectional area of the piston? They want us to find out this area. Okay. So basically, what we want to plan here is that we are given with work done, okay, and we are given with some pressure and some height and some area is required. That's nice. So I have to work my equation for work into pressure, height, and area. Hmm. So we can start up with basically force times displacement, right? So instead of writing force, I can write pressure times area, right? Reason being, we know P is equals to F over A. So F is going to be P times A, right? So instead of writing F, I can just substitute it like this. So that gives me pressure in area, and that's equals to work. Now, displacement is basically clearly given. That's 0.50 meters. So I think we now know everything. We know work done, we know pressure, we know area, and we know displacement. So let's just substitute it. So 11 kilojoules, that means 11,000 joules equals to pressure. That was 2.2 exponent 5. Area was given. no, area is required, and displacement is given. That's the displacement the piston had. That's 0.5. So now let's find out the area. So answer comes out to be 0.1. That's basically D. Okay, do you guys get this? So what I did, I substituted force as pressure into area, and displacement comes as it is. I was given with work, I was given with pressure, area was required, and displacement is the distance that is moved while the force is applied, right? So this piston moves upwards during this, displacement. So that's the displacement that is given. So I just plugged in all the values and I got my answer for area. Let's try question 6. So it says a sledge of mass 50 kilograms sits on a snowy surface. Okay. It is pulled horizontally for 10 meters against a frictional force of 200 Newton. So snowy surface, there is a sledge and it is pulled horizontally and there is a frictional force. It is pulled for 10 meters and frictional force of 200 Newton is there. Okay. Then it is pulled horizontally across ice for 10 meters. So once this snowy surface ends, there is an icy surface and the same sledge is pulled now 10 meters on icy surface. There is no friction between the ice and the sledge. So there is no friction, zero friction here. And what else? It is lifted up vertically by 1 meter and finally carried back at a constant speed where it started. Okay, so it is lifted up vertically by 1 meters. That means it is then, lifted up by 1 meters. Okay, so, and then finally carried back at a constant speed, and then finally carried back at a constant. Okay. During which stage of its journey is the most work done? Okay. So we have to figure out the amount of work done on each of the components here, and then we have to figure out which one is the greatest of all. So this is 10 meters, and that's 200 newtons. So frictional force and work done would be 2000 joules here, right? And then here, there was no friction. So practically speaking, zero work. Then moving on, it is lifted 1 meters. So if it is 50 kilograms and it is lifted 1 meters, so just multiply it with 9.81 times 1. So let's assume this to be 10. So that's going to be 500 joules max, right? And then constant is speed. That means there is no change in uh, speed. That means there is no gain in kinetic energy. So change in speed is zero. So no kinetic energy gain. So basically the maximum work done is on the snowy surface, right? So we have something like that. Yeah, we have being pulled 10 meters across. Do you guys get this? 6 is going to be D. Nice. Zabardast. So we can move on to question number 7. Question number 7, you guys can read it for a while. I'll read it for you guys. The gas in an engine does work on a piston across a cross-sectional area, quite similar to the question we just did. So 25 centimeters, and then this is basically pushing it against. The question says how much work is done. So we can do work is equals to pressure into area into displacement, right? Do we have pressure? Yeah, we have pressure. That's 4.6 exponent 5. Do we have area? Yes, that we have an area, but it is not in square meters. It should be in square meters. So from 1 meter to 100 centimeter, right? So if we want to relate squares, what we can do? We can just do squaring on both sides. So this would be 1 squared meters equals to 100 squared centimeters. So if we want to convert from centimeter square to meter square, we have to divide with this value. So it is going to be 80 exponent negative 4, right? So that's area. Displacement is given, that's 25 centimeters. That's going to be 0.25 meters. You just have to multiply all of them. What's your answer? 4.6 exponent 5 times 80 exponent minus 4 times 0.25. So I got 920 joules, which is going to be A. So do you guys get this? No. Lovely. Let's try question 8. Question number 8. So it says an electrical motor produces 120 watt of useful mechanical output power. So that is important. That's output useful. The efficiency is 60%. Okay, which was correct? Electrical power input and waste heat. Okay. They want us to find out. Mohammed Saad, work done was force times displacement, right? Force is just replaced by pressure multiplied by area. Since we know pressure is force acting per unit area. So times D. Do you get it now? Okay. So where was I? Yeah. 120 watt, and then it is basically it is efficiency 60%. They want us to find out input power and waste heat. Okay. So first we can use efficiency formula, that is going to be useful power output over total power input times 100, right? So efficiency is going to be 60. Now there is a very important discussion here which needs to be done before we proceed with the calculation. See, once you write 60%, once you see 60%, everyone gets excited and they write 0.6 instead of 60 here. So if you write 0.6, that's totally okay. But then you don't have to write 100 here. Just eliminate it. So either you do this or you do this. Okay? So yeah, do you guys get this? That is very important. Don't do 0.6 and then then writing 100 is going to give you incorrect answers. That's incorrect. So once you write 60%, you're going to do. So let's find this out, PI. So power input is going to be 120 times 100 divided by 60. So what's that? So, so that's 200. So that's somewhere between C and D now. Okay. So 200 was the total power input, right? And out of that 200, useful was 120, right? So power output was 120. So amount of waste is always going to be then 80 watt, right? So that's going to be D. Okay, do you guys get this? I'm still waiting for your response, Mohammed Saad. Nice. Okay, let's try. Achha, it looks quite similar question. Distance. you know. Let's try 10 wala question. This is given. This is 60% given. 68% is the efficiency.
My bad.
Okay. So let's try this question. Question 10. So the question here says, during the change when work is done on the gas by its surrounding, how much work is done on the gas? So a fixed amount of gas undergoes a series of changes to its pressure and volume. In two of the changes, no work is done by or on the gas. In one change, work is done by the gas on its surrounding. Now, what does that question has to mean? So basically, they want us to imagine a cylinder, and then in that cylinder, as you guys just saw in the question we just did, there is a gas, right? And then they're using this term, work is done on the gas or by the gas. So if this gas basically kind of expands, it may expand due to heat given to this, it may expand due to thermal conductivity, anything like that. So let's say if we plan to heat this gas up, so this gas is going to collide with this piston more rigorously. As a result, this is going to move up, right? So we can say gas is doing work or system is doing work. So that system is doing work. This is what they say, work is being done by the system. Obviously, if system is doing work, then system has to work on surroundings, right? So everything other than the system is surrounding. So if work is done by the system, that's going to happen. So that's expansion. Okay. So do you guys get this part? Now the reverse would be compression. So if we have something like this, and the gas instead of being heated up is cooled. So if let's say we are planning to cool this gas up, so what is going to happen? This piston is going to come down. Or basically if someone just adds some weight here, this piston is going to move down, right? So that's work being done on the gas or work being done on the system. So that's the terminology here. Work is done on the system. Okay. So that's compression. Compression means to decrease the size of a gas molecule of a gas, and to expansion is to increase the size. So that is system doing work or work being done by gas. That's work being done on gas. Now that's the background of this question. They want us to know. Okay, fine. Now they say during the change when work is done on the gas, how much work is done on the gas? So just looking at this pressure volume diagram, how can you say, work is being done on the gas? So just remember, I told you expansion is where gas does some work, right? So they're not talking about expansion. They're talking about compression. Why? Because that's where surrounding is, doing some work. So where is expansion or compression happening? So if we see these arrows, it shows volume going from 5 to 2. So that's compression. So this is compression, right? And this is going to be expansion. Reason is volume, you can see very much clearly. This is increasing from 2 to 5. So we have to find out work done for this process only. Okay. So do you guys understand the question? Before we proceed with the calculation. So now the simple formula that was force times displacement, but they want us to find out volume. So they've given us pressure. Now this product, area times displacement, basically is volume, right? Why? Because area is a combination of two lengths that That's length into breadth, and displacement is another length. That's basically again in meters. So length into breadth into displacement, that's basically volume. So instead of writing P into A into S, I can just do PV. And in certain books, we do P delta V. So both are acceptable, PV or P delta V. Acha. Okay. So do we have value of P here? Yeah, we have. That's 1 exponent 5. Do we have change in volume from 5 to 2? So basically the volume is going to be 3 exponent minus 4. So that's going to give us 30 joules. 1 exponent minus 5 and 3 exponent minus 4, 30 joules. So do you guys get this? Question was very easy, but the background story is a bit complicated. Nice. Let's try this. Question number 11. Okay. So it says trains supply coal to a power station. Okay. The table shows quantities. Power station average output, that's P. Okay, that's output. Number of trains per day, that's N. Mass on a coal train, that's M. Energy from 1 kilograms, that E. Number of seconds in 1 day, that's S. Which expression gives the efficiency? So efficiency is going to be output power over input power, right? So output power is basically P. We can very much see that. Input power is going to be, so the understanding is there are trains which are carrying some coal and they're running towards a power station, right? So trains, they have coal. So coal is a source of energy, right? We know this. So the total number of trains and the total number of energy supplied or the total power supplied, that's what we have to find this out. So denominator should be power output is P. Denominator should be basically if we see power input, right? So instead of power, what we have is energy. So no, C is not a correct answer. Output is basically P, right? So we have to think between A and B, right? Don't think about C and D. So they say N, which is number of trains per day. That's nice. And M is going to be mass of coal on a particular train. And E is going to be the energy. And why do we have seconds? Why? Because yeah, that's quite obvious. Because this expression gives us the total amount of energy that is carried by number of trains having m mass of coal. So that's energy. But we intend to work out power. Why? I told you guys in the class that whenever you are working with efficiency, if numerator has power, denominator should also be power. So that's energy. In order to convert energy into power, I can just do divide with time, and time given is in seconds, right? So that's S. So this goes S basically is denominator. So this becomes numerator. So that's what is written P divided by NME over S. So that instead can be written as P times S over NME. So PS, that's A. So do you guys get this? See, basically they wanted us to find out the expression for power station's efficiency, right? That's output power over input power. So output power clearly is given that's P. So input power basically has to have energy per unit time, right? Because power is energy per unit time. So energy supplied by 1 kilogram is E, We don't have, we are not having only 1 kilogram. We don't know what amount of mass we have. So each train would be carrying, thousands of kilograms of coal, right? So we multiply E with N, and there aren't, they are not saying that they have only one train running per day. There are number of trains, that's N. So each train carries coal, and it supplies energy. So instead of, getting too much complicated here, let's keep it very simple. Time is basically not T but S. So once you solve this expression, this is what you get, right? सही है, समझ में आ गई बात? Okay, that's nice. Sure. So I think similar questions are done. Let's see. Let's try this rope part of. So it says a rope is attached to a sledge and a boy uses the rope to pull the sledge with constant velocity. That is important, with constant velocity. The tension in the rope is 100 Newton, okay, and it is held at 30 degrees. How much work does the boy do on sledge? And he pulls at a distance of 5 meters along a surface. Okay. So basically, this offers certain friction, maybe. So there obviously is no work done in kinetic energy, but there should be some friction because this guy is experiencing a force here. So we have to just find out. They've already given us this distance. That's 5.0 meters. We have to just find out the direction of the component force parallel to this. So if this is 100, so this is going to be 100 cos 30, and that's going to be 100 sine 30. Obviously, 100 sine 30 is not going to be used. So that's 100 cos 30 times 5. So what do we have? 100 cos 30 times 5. 100 cos 30 times 5. So I got 433, which is C. So do we get this? Nice. I think the other questions look similar. This is what we already done. Let's try. This is already done. These type of questions are already done. This is already done. This looks something different. Let's try this. Question number 42. So I have an answer. A, okay. Let's find this out. It says an electric motor has an input power, that's P input, okay. And then the motor's efficiency is given by N. And then they want us to find out power lost. Okay. And then the output power is P out. Okay. Nice. So how much power is lost by the motor? That's the question at place. So using the formula for efficiency, we know that that is going to be power output over power input, right? So that's one of the things. Now, uh, if we relate power output, power lost, and power input, so what would be the mathematical relationship? See, power input is going to be equals to power output plus power lost. Do you guys agree to this? Rest is, I think, very easy. They want us to find out power lost, right? That's what they want us to find out. Power lost. So if we just plug this in here, so that's going to be power input equals to power output. If I just bring this here, so power, instead of writing power output, I can write this. No, but I do need power output. So let's get rid of this power input. Yeah. So if I calculate the value of power input, so that would be somewhat like this, right? Power output over eta. Yeah, makes more sense. Let's plug this in here. So that's going to be power output over eta is equals to power output plus power lost. So if you want to figure this out, so that's going to be power output over eta minus power output is equals to power lost. So that's power lost. So if we just uh, factorize this, so that's going to look somewhat like this. Power output over 1 over n minus 1 is equals to power lost. So this is incorrect. This relates to power input. I don't have power input. That's power output. Well, that's correct. D is correct. So do we get this? Is this understood? Nice. That's nice. That's nice. Let's try some other questions. This looks difficult, but this is very easy. Want to try this? 43. So So the diagram shows a barrel of weight this much Newton on a frictionless slope inclined at. So I think we just did this type of a question, right? This looks difficult. So we have weight and we have the slope. What is the work done in moving the barrel a distance of 5 meters? So we just did that sledge wala question. So it's going to be the same thing. If you find this out, so that's going to be 5 sine 30, right? So that's 2.5. 2.5 times 1 exponent 3. That's height. So work done would be equals to GPE. That's mgh. So instead of m and g, we have 1.0 exponent 3 and h is 2.5. So that's going to be basically 1 times 2.5. That's 2.5 exponent 3. That's it. Might only looked difficult, right? So do you guys get this? Is this understood? I think they're all similar. Yeah. This looks too much maths. Let's try this one. 50 wala question. So efficiency is still the same thing, efficiency. So data below are taken from a petrol engine. Okay. So power output, so efficiency is going to be power output over power input. So power output is 150 kilowatts. So 150 I see here, 150 I see here. Well, I see 150 everywhere. So let's do something more than that. 150 kilowatt. Okay. Divided by power input. So power input fuel consumption 20 liters per hour. So that's 20 liters per hour. Okay. Energy content of the fuel, it's 40 megajoules per liter. So 40 megajoules per liter. Okay. Nice. So the total energy supplied would be per liter, my fuel is going to give me 40 megajoules. Okay, so that's supplied 40 megajoules, exponent 6. That's per liter. And fuel consumption is 20 liters per hour. So that's going to be 20, right? And that's per hour. So in order to convert it into seconds, I need to multiply it with 3600. So either I divide this with 3600 or I multiply that with 3600. So that's the same thing. You just learned that. Basically, this is going to be 150 exponent 3, 150 exponent 3. It doesn't have 60, doesn't. So it looks like this is going to be B. So do you guys get this question? Is this understood? Nice. 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 Saad has sent me a question other than the past paper. Saad, we can do that question later on. Right now, we are focusing on something else. So, okay. So, let's try a few last questions. So, this is the curve that says a ball is dropped from rest and falls towards the ground. Air resistance is negligible. Which graph shows the variation with the speed and height of the ball? So, this is going down. They want us to find out the relationship between height and speed. So, air resistance is not there. So, as it gains speed, height should decrease, right? So, this is not possible. This is not possible. So, it's either A and C. So is it going to be like this or is it going to be like this? So basically we need to relate these two. So equation of motion is going to help us here. So since there is no air resistance, that means acceleration is constant. That's C. So I can write 2gh is equals to v squared minus u squared, which is going to be 0 because this falls from rest. So the relationship is 2gh equals to v squared, right? That means v and h are not linearly related. They are related with a square. So equation of a straight line is not applicable here. A curve is applicable. So I'll go with C. So do you guys get this? Nice. So it was already solved. Let's try this question. That is question 3. We have done a similar question, but that never included values. So it says there is a ball that slides down from X to Y. Okay, what is the ball speed of the ball at point Y? I want us to find out the speed. So the conversions would be potential energy to kinetic energy. They say frictional forces are negligible. So this is not going to give us any kind of height. So GH is equals to half V squared. G is 9.81. Height is 0.40. Half V is unknown, right? So no. They have given us kinetic energy at X also, right? So mgh plus half mv squared equals to half mv squared. So that's the kinetic energy at X. That's the kinetic energy at Y. So they want us to find out this. They never want us to find out anything other than that. So basically, m can be factorized throughout the equation since m is same. So I can write gh plus half vx squared is equals to half vy squared. So let's do GH. That's 9.81. H is 0.40. Half as it is V1. Vx, sorry, that's 2.5 squared. Half Vy squared. So Vy comes out to be what? So 9.81 times 0.40 plus zero point 0.5 times 2.5 squared. That's 7.049 times 2. And then we have to find out the square root of the answer. Square root of the answer, and then again the square root of the answer. So I'm getting 2.3.75. 3.75. That's C. So do you guys get this? Is this understood? Let's try this. It says, it looks like, what is that? So an object is moved in a vertical plane from X to Y and then Y to Z. Okay, there is an object here. Okay, this goes here. This goes everywhere. This starts here. This goes like this. Okay. The distances are between the various points are indicated. Okay. Okay. So object weighs 20 Newton. How much gravitational potential energy does the object gain by moving from X to Z? So basically it starts here, it goes down all the way here, and then it goes up all the way here. So this path basically cancels out. So the only gain it does is this. So if weight is 20 Newton, so this distance is 3 meters. So that's going to be 60 Newton meter. That's A. So do we get this? Acha, basically we are doing it with a faster speed. This looks like something worth trying. So question 7. It says that the steel ball is falling at a constant speed and all. Constant speed. That means kinetic energy is constant. Okay. So kinetic energy can't change. Kinetic energy can't change. It's somewhere between it. This graph shows the variation in the time of the gravitational potential energy and the kinetic energy. So something is falling at constant speed. That means gravitational potential energy is going to decrease, right? So potential energy is going to decrease. So is it going to decrease quadratically or is it going to decrease linearly? So basically potential energy is related to mgh. So potential energy and h are linearly related. So this has to be B, not A. Do you guys get this?